Okay, let's give you guys some more practice. So now we are on the moon. Gravity on the moon is this. You're going to fire the cannonball at 60 meters per second at an angle of 29 degrees. Find out the exact position of the cannonball after 10 seconds. Okay, so when you fire the cannonball, it's going to travel something like this. Now the question is well, so 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 after this point here is time it takes to get to the maximum height. Let's call it T max. Now, is 10 seconds here or is it here? So at 10 seconds, is the cannonball rising or is it falling? So you see, you have no idea. Just by looking at this problem here, you have no idea where T max is, and you're asked to find out the height of the let's say it's here, the height of the cannonball. Well, you've got to find out the height of the cannonball and the distance here of the cannonball after 10 seconds. But the thing is, given this problem here, you have no idea whether t equals 10 is before t max or is after t max. So the first thing you should do is work out the time it takes to get to maximum height, just so that you can get a rough idea of what's going on. Well, it's up to you how you do this. So after 10 seconds here, let's say the cannonball's here, or it could be like this, or it could be over here. So let's say, yeah, find the exact position. So I want the height of the cannonball and the distance here, from the cannon to the cannonball after 10 seconds. Okay, so press pause and have a go. Okay, so the first thing you should do is break. Hang on. Break break this up into its vertical and horizontal component here. Okay, so vertical would be this. Horizontal would be this. So now jump to your velocity time graph, and this point here is the initial. Remember, rather than looking at us shooting the cannonball diagonally, we're just going to shoot the cannonball vertically upwards like this, and then plot. Well, get all the calculations from this scenario here, where we are just firing the cannonball vertically upwards. So this graph represents us firing the cannonball vertically upwards. So this point here is the initial velocity, vertical velocity here. So remember, we are firing the cannonball vertically upwards, so it's going to go like this and down again. So this is the initial velocity here. So the equation for this graph here is given by this. Okay, now we want to know T max. So T max, the velocity would be 0. So let's put 0 into the V and work backwards to find out the time it takes to get to the maximum height. Okay, so you put 0 into the V. So this thing here becomes this, and then work backwards to find out T, which will represent the time it takes to get to maximum height. So T max is given by this. Okay, you punch into your calculator, you will get this, and well, what that means is well, this is the time it takes to get to T max. So what this means is that T max is from here to here. Okay, hang on. From here to T max, it takes 17.93 seconds. Now, if it takes 17.93 seconds to get to the maximum height, well, our question says that, well, find out the height after 10 seconds. So T equals 10 is before the maximum height. So what that means is that when you're firing it like this, it takes 17.93 seconds to get to the maximum height. But the question is saying, find out the position of the cannonball after 10 seconds. So 10 seconds is probably somewhere, I don't know, somewhere around here. So the cannonball is still rising. Don't forget, gravity on the moon is very weak. So So the pull downwards is also very weak. So that's why it goes. Well, that's why it's able to travel so far. Well, anyway, so we are interested in t equals 10. So now we want to know the area of this trapezium here. Okay, so the area here represents the height, represents the well, it represents the height here. So if it's like this, t equals 10 here, t max is here. The area of that graph there represents this height here. So we need to work out this the area of this trapezium here. So you can imagine it as like this. So we're just gonna get this height here, which is the initial speed here, which is 60 sine 29. Okay, and then this bit here. Well, let's put 10 into this equation here, because this line here is given by this equation. So if you put 10 into this t here, this v would represent the height right here. Okay, so put 10 into the v here, into t here, and then work out v. So that will give us this height here. Okay, this height here. So put 10 into here, and then that will give us a height here, which happens to be 12.83, 12.87. Sorry. So this height here is 12.87. Okay. Now this height here is 60 sine 29. So all you have to do now is get this height, which is this, plus this height, which is this. Okay, and then divided by 2, that will give you the average. Divided by 2 here, and then times the across here. Well, the across here, don't forget, the across here is 10. So we just need to times it by 10. So the height, h10, the height at 10 seconds. Well, you're allowed to invent your own symbol here. I've invented as height. This 10 here represents at 10 seconds. Okay, so height at 10 seconds will be given by this. Okay, so what that means is t max is here, t10 is here, the height is given by this. See, and then now we still need to know this distance here. So the horizontal distance would be well. Don't forget when we broke up the components, it's 60 cos what is it 29 here. Don't forget, this is the speed of well, come to this stage. Imagine you and your dad sitting in a car here, and your dad is traveling at this speed here, 60 cos 29, and then well, you remember you're traveling for 10 seconds in this direction. So just get 10 times by this thing here to give you the horizontal distance. So basically, this is the initial. Well, this is like the speed of the car here, and then you times it by 10. So now get this, merge it with the 60. So that would be 600 cos 29. So this is the horizontal distance here. Okay. Well, I'm just going to leave it as this rather than converting to a decimal. So you are allowed to do that. So the horizontal distance is given by 600 cos 29, and the height is given by this. Okay.